Assalamu alaikum and hello everyone. Today we are going to continue Chapter 7 Energy. Coal, crude oil, and natural gas are common sources of energy, but they will not last forever. Once depleted, they will not be available for future needs. They are known as non renewable sources of energy, whereas sources of energy that can be used repeatedly and will not be used up are known as renewable sources of energy. Some examples of renewable sources of energy are hydroelectrical power station, geothermal energy, fuel cells, biomass, solar energy, wind energy, and tidal energy. Another alternative for non-renewable resources is nuclear energy. Before we get into the detail of alternative sources of energy, let's recap on how power station works. A source of energy, like natural gas or coal, is supplied to the power station to generate electricity. The electricity is then transmitted through transmission lines to a local substation. The substation finally distributes the electricity to houses, shops, and other buildings. Electricity is generated in the generator as kinetic energy from the moving turbine is converted into electrical energy. A turbine is a device that can turn like a fan and harness kinetic energy to generate electricity in the generator. Hydroelectrical power station. A wall is built across a river and causes the water to rise behind it, so forming a large reservoir. This wall is called a dam. Let's see how a hydroelectrical power station generates electricity. Water stored behind the dam is called the reservoir. The water level in the reservoir is higher than the position of the turbines, so the water has gravitational potential energy. Water from the reservoir flows through the turbines and the turbines turn rapidly. So, gravitational potential energy of water from the reservoir is converted into kinetic energy of moving water and then converted into kinetic energy of the turbines. The turbines are connected to the generators that produce electricity. Therefore, this is where the kinetic energy of the turbines is converted into electrical energy in the generators. Geothermal energy. The source of geothermal energy is the Earth's core. The structure of the Earth consists of crust, mantle, outer core, and inner core. The core and mantle of the Earth are very hot. Now, let's see what geothermal is about. When it rains, rainwater would fall on land and seeps into the soil. Sometimes there are empty spaces formed deep beneath the ground. These spaces, or cavities, is filled with water as water from the surface above seeps into the ground. The mantle of the Earth mainly consists of hot rock and magma, which are extremely hot. Because of this extreme heat, the water in the cavities becomes hot and may also turn into steam. The hot water or steam can rise to the surface above and form geyser and hot springs. So this is the basis of geothermal energy. What may also help you remember what geothermal means is that geo means earth and thermal means heat. So geothermal basically means heat from the earth. This is a geyser. It is where hot water or steam would burst out from the ground. And this is a hot spring. It is basically a pool of hot water. Now, how can we use geothermal energy as a renewable sources of energy? Hot rocks found deep underground heat up the underground water, turning it into steam. The resulting jet of steam is channeled to a turbine that can be used to generate electricity. Fuel cells. Fuel cell is a device that converts the chemical energy in fuel into electricity. An example of a fuel cell is the hydrogen fuel cell. It makes use of hydrogen and oxygen to produce electricity. Hydrogen can be obtained from natural gas and the electrolysis of water. Let's recap a bit on electrolysis from Chapter 3 Matter. Electrolysis of water is when water is broken down into hydrogen and oxygen by electricity. By passing an electric current through the water, it will be chemically broken down into hydrogen gas and oxygen gas. When hydrogen fuel cell generates electrical energy, it also produces heat and water as a byproduct. Some uses of hydrogen fuel cells are in space vehicles as well as in some cars. Biomass. Biomass is organic matter that can be used to make fuel to produce heat or electricity. It can be obtained from plant and animal waste. Biomass resources can be restocked through cultivation of crops such as fast-growing trees and grass. When organic waste from plants, food, and animals decompose by bacteria, they release biogas such as methane. Biogas can be used as fuel in power plants to generate heat and electricity. Solar energy. Solar energy comes from the sun. Solar water heaters placed on the roof of a house trap the sun's heat to produce hot water for household use. It may also be converted into electrical energy, which can be used for household appliances. Solar cells that are placed on a roof absorb sunlight during the day and convert it to electricity. It can generate enough energy to power a whole house. However, one disadvantage of solar panels is that they are expensive. This is a solar-powered calculator. Solar-powered calculator has solar cells in them. They can be used at night because the solar cells store all the energy that was absorbed by the solar panels. Wind energy. Wind turbines use kinetic energy of wind, which is wind energy, to generate electrical energy. So, how does a wind turbine works? Wind causes the blades to rotate. Then, the shaft turns the generator to produce electrical energy. Wind turbines are set up in a large open area of land or sea called a wind farm. The disadvantage of a wind turbine is that it can only function in the presence of strong winds. Furthermore, it needs open, windy areas to operate. Nuclear energy. Nuclear energy is the energy source when radioactive metals, such as uranium and plutonium, break down into lighter atoms, releasing large amounts of heat energy. Radioactive substances are substances that are unstable and breaks down easily. In nuclear power plants, this radioactive reaction happens in the reactor vessel. The heat boils water to generate steam, which turns the turbines in the nuclear plant and produces electrical energy. Nuclear power stations produce dangerous waste and radiation. Radiation is a type of powerful light energy that is not visible and can be harmful to the surrounding. This radiation can cause cancer. On the 15th of March 2011, a powerful earthquake hit Japan. The impact damaged a nuclear plant in Fukushima, Japan, forcing people living in a 20-kilometer radius from the plant to evacuate. To evacuate means to leave a place of danger to a safer place. Some of the workers suffered radiation burns as a result of the incident. Tidal energy. Tidal power stations convert potential energy of the tide to electrical energy. A long wall is built across the mouth of the bay. At high tide, The sea water flows through the wall to get into the bay. The sea water flows through the turbines placed along the wall, causing the generators to turn and produce electricity. At low tide, the water in the bay flows out to the sea through the same turbines, and again, they will turn the generators and produce electricity. This continuous movement of the tides allows the generation of electricity as the turbines are driven by the power of the sea in both directions. And that is the end of Chapter 7 Energy. Well done, everyone. Thank you and see you in the next topic.